So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about tips and tricks for sheet metal design and Onshape. It's really intended for those that are doing sheet metal design and are interested in kind of the basics and some tips for working with sheet metal parts. So that's going to be the focus for this webinar. As I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions section in the GoToWebinar control panel. Feel free to type in any question, and I'll do my best to stop and answer the questions as we go through these webinars. So again, tips and tricks for sheet metal design. If you're doing sheet metal design, this one is definitely for you. So let's dig into it. Now the agenda is pretty brief, pretty straightforward. We're going to start with a simple introduction to sheet metal design. So we're going to start with the basics. What is sheet metal design? Where would you use it? And then we're going to get into how it's done in Onshape. So we're going to focus on the 3 ways that we have to create a sheet metal part. And then we're going to dig into tips and tricks. And tips and tricks are really just based off of a lot of frequently asked questions that we get. So we get a lot of questions in these webinars and other sources of how do I do this? How do I do that? And so we thought we'd put together a webinar discussing some of those questions. So we're going to start with the basics, introduce you to sheet metal, introduce you to how Onshape creates sheet metal. Then we're going to get into some tips. Now, as I always say, again, feel free to ask any question. There's a questions section there in the GoToWebinar control panel, and I'll do my best to stop and answer them. All right, so let's get into it. Now, the question that gets asked often when you're first getting into CAD, if you're not familiar with the manufacturing process or CAD in general, is what is sheet metal design? What's the difference between sheet metal design and the normal extrude command that I use every day? And there's a few key differences. Of course, sheet metal design is about designing sheet metal parts, and sheet metal parts have a very specific requirement. They're made from a uniform sheet of material, right? So they have some specific design requirements. The biggest being you must have a uniform wall thickness, right? A sheet metal part starts as a uniform sheet of material, so therefore your part must have uniform thickness, a uniform material thickness. And you also have the need to unfold. That's another requirement of sheet metal parts. You must be able to unfold them because that's how they're created, right? So these requirements dictate a certain type of design, right? You have to design a certain way. And so when we talk about sheet metal design, I think the key thing to keep in mind is the design in sheet metal must have the same thickness throughout, and it must have the ability to unfold. If those two things can't happen, then of course it can't be a sheet metal part. Now, the other important caveat to this, it needs uniform thickness, it needs the ability to unfold, but it also has to be able to calculate what's called K factor. K factor is simply the amount of stretch that you get based on the bends that you're creating. And K factor is entered in as a value to determine what that final unfolded part should look like, what the length of the part should look like, and all of that. And then when you start to calculate the amount of stretch that you're getting for each bend, factoring that into the overall part is an important part of it. And so K factor, you'll see this when we start our sheet metal parts. The key thing is you're determining the amount of stretch. And it's an important factor if you're going to take that flat view and bring it into a water jet or laser cut or whatever the operation may be. The other thing that we do with sheet metal design in Onshape is we allow you to establish the default bend radius, default corner relief, and bend relief, and other settings as a default. So right away as you get started, you create that initial sheet metal feature, you define your K factor, you define your bend radius, your corner relief, and all those things. All right, so that's a simple introduction into sheet metal design. I think the key thing to keep in mind, uniform thickness, the need to unfold, and the K factor to apply that stretch to the material for the bends. So the next thing I want to jump into is the tips that I have for you. And the first tip, admittedly, is basic, and that is how do I create a sheet metal part? And there are 3 ways to create a sheet metal part in Onshape. We have the ability to convert a solid, we have the ability to thicken faces, and we have the ability to extrude an open profile. So 3 different ways to create a sheet metal part in Onshape. I'm going to show you an example of all 3 in just a moment. But tip number 1, again, remember, you don't have just one technique. You have 3 to create sheet metal parts. Could be a solid, could be a face, could be an open sketch profile. All of those work. So let's jump into it. Now, as I mentioned before, I want to start really basic, and I want to show you the 3 ways that we have for creating sheet metal parts. And then we're going to jump into some more advanced sheet metal tips. So as I mentioned before, there are 3 ways. You'll find all 3 in the Start Sheet Metal Model command. So at the far left of the sheet metal tools, you'll find Sheet Metal Model. And at the very top of this command, you'll find the 3 ways that we have to create a sheet metal part. So we have Convert, Extrude, and Thicken. Now, Convert is useful in an example like this, where I have a part that I want to convert to sheet metal. For instance, I'm designing this enclosure for some parts and an emergency stop button and just this, miscellaneous electronic components. And I need to design a sheet metal enclosure for that. That's where I would use Convert. I've already constructed this solid part that represents that enclosed volume that I want to create out of my sheet metal, and now I can easily just convert it. Now, very simple, when you choose Convert, you just choose the part that you want to convert. What happens is it applies a sheet to each one of the faces in that part. It's your job then to go in and define what are the edges to bend and the faces to exclude. So naturally, your edges to bend, well, I want, this should be a bend. If I left click that edge, it converts it from a rip to a bend. You can see it's a bend now. And, this edge over here should be a bend. So I'll come over here and select this edge. You'll notice it converts it. Now that's a bent sheet metal part, and we'll come around to the back here as well and select that edge. Okay. Now notice it automatically adds things like the corner relief, right? So when I create a situation that creates or warrants a corner relief, it's automatically done for me there. So I go through and I define each of the edges that I want to be bends, right? I've gone through and defined those 3 edges. Those are the bends that I want to create this initial sheet metal part. I need to then go in and define faces to exclude. And I'm just going to select these top 3 faces. We're going to create a separate sheet metal part for the top piece of this electronics housing. Now, I mentioned before, you can establish the default bend radius, K factor, bend relief types, and so on. All of that is done right here. So when you first create your sheet metal part, as we're doing here, you're going to define, here's my bend, here's my thickness, here's my bend radius, here's my K factor. Another commonly asked question, how do I change the default bend relief type? From all brown to rectangular, you can do that here. I can do sized corner reliefs if I choose to. Another commonly asked question is, how do I apply a corner relief that's a known size? I want a 1/4 inch corner relief cut, and I don't want it scaled. I can define that under round sized or square sized, depending on what you're doing. So my point in all this is you're defining all of these default sheet metal settings. For every feature that you create going forward that's associated with this sheet metal part, it's going to have these settings. The last thing I want to do before I accept is check the box Keep Input Part. And that's only to keep that solid part that we started with. Remember, I sketched and extruded just a simple volume to represent what I wanted to create a feature out of. And we're going to keep that part. So I'll hit the green check, and now we have our first sheet metal part. So if I hide my volume here, go all the way down to the bottom, you can see part 52, there's my sheet metal part. Now, the natural question once you've got a sheet metal part is, how do I view the flat view? How do I go in and see all that information? And it is a bit different than other CAD systems in the sense that you get a real-time view, a simultaneous view of that flat view in the sheet metal table and flat view tab. So if you click this icon on the right, you get the sheet metal table and flat view flyout. And this will show you your flat views and a table giving you all the details of the bend information, any rip information, all of that in a single place. The neat thing I always like to mention about this is if you make a change to the model, this updates live. So you don't have to make a change, rebuild, see if something fails, and then go back and forth. You can instantly make a change here, and it will update in the flat. So this is how you access your flat view. One other thing I want to point out, we'll get to this in greater detail later, is it's dynamic. If I select a joint here, it highlights it here, and so on. Now, the first technique that I showed you for creating a sheet metal part is converting a solid. So I took that solid envelope that we started with, just a simple extrude, and I converted that into sheet metal part. Right? Now, the second technique that I want to show you is the process of thickening faces. So instead of taking an entire solid volume, we're just selecting a few specific faces and saying this is going to be our sheet metal part. So I go back to the same sheet metal command. So it's important to remember, no matter what technique you're using to create a sheet metal part, you're always going to that same command in the toolbar. Now, the difference being, the first time we created a sheet metal part, we chose this option to convert, but this time we want to choose the option to thicken. Remember, we're thickening faces. That's the way to think of this. And then you just select the faces that you want to thicken into sheet metal. So I'll select this, this, and this. So I've selected 3 different faces to thicken. Then I go in and define my edges to bend, right? And I can select the edges here and here, and now that's one sheet metal part. Remember that edges to bend joins them into a single sheet metal part. By default, if I just select the 3 faces, I'm creating 3 different sheets, on top of each. So again, edges to bend, and then it's really all the same as we had in the past: thickness, bend radius, K factor, corner relief types, bend relief types, and so on. So I establish all of that. I hit the green check. Now I have my second sheet metal part in this part studio. Remember, we created the first one just using the convert and converting that solid. We created the second one by offsetting those faces. Now, the third technique, and I think the third technique is going to be very common if you've come from other CAD systems, a very popular technique in other CAD systems, and that is simply sketching an open profile and extruding that profile. So let's hide a few of these parts here. And you can see I have a simple open sketch here. Just a few lines, line here, and it's just a simple open contour. Now, this is the third technique that we have for creating a sheet metal part, and that is to take a sketch like this and extrude it. So again, to recap, we converted the solid, we offset the faces. Now we're going to extrude this open profile to create a sheet metal part. Again, I go back to the same sheet metal command in the toolbar. So on the far left of all the sheet metal tools, you have sheet metal model. This time, though, we're going to choose the option to extrude. And from there, you can choose the curves that you want to extrude. Now, you can choose them one at a time in the graphics. I can left click them individually here, or I can just select the whole sketch from the feature list, and it will grab all the geometry in that sketch. So, if I don't want to left click individually each line, I can just select the whole sketch. And from here, it's very similar to a normal extrude, except, of course, you have settings like thickness and bend radius and so on. So in this case, we'll do symmetric. We want a symmetric extrude, let's say 95 millimeters depth. Right, there we go. And then again, thickness, bend radius, K factor, corner relief types, bend relief types, setting all those default settings for this new sheet metal part. So for every new sheet metal part that I create, this is the third in this part studio that I've created, I need to go in and establish all those default settings. But again, every subsequent feature that I add to these sheet metal parts, that will be the default. So that's the neat thing about establishing all of that here. So I hit the green check, and now we have our third sheet metal model in our part. Right? So we have 3 sheet metal parts created using the 3 different techniques that we have for creating sheet metal. So again, 3 ways to start sheet metal: converting a solid, extruding an open profile, and thickening a face. All right, so a few questions. Does the concurrent flat view show bending dimensions and bend allowances? It does not show that dynamically, no. You will get bend information if you insert the flat view into the drawing. That will come in automatically. But it's not bend allowance, it would just be bend radius information, and then the bend center line. But you don't see that in the flat view, no. You just see bend lines, I believe. How do you make the emboss? I'm going to get to that in just a moment. In fact, that's one of my tips. Any kind of standoffs or anything that you would weld to a sheet metal part, if you think of it that way, we're going to cover in just a moment. The key there is the finish sheet metal command. You must finish the sheet metal, then you can add any kind of normal solid feature that you want. Emboss, standoffs, gussets, any of those kinds of things. that would be done as like a post-processing operation to the sheet metal part, you would want to finish the sheet metal first. I'm going to get to that in just a moment. All right, so tip number 2, selecting in the folded view highlights the flat view and vice versa. So the area I think is really useful is more complex sheet metal parts where you're trying to understand how the flat view relates to the folded view. Because in those situations, it may not always be obvious. The thing I would stress is if you select a bend in the folded view, it will highlight in the flat view so that you can see the two corresponding. You can even select an edge on the flat view and start a flange, for instance, because it's the same thing as selecting the edge on the folded view. So the thing I would stress is it's very easy to know, okay, this bend is this in the table, because if I left click it here, it highlights in the table or the flat view. Same thing goes if I highlight something in the table, it highlights in the folded view and the flat view. So no matter what you select, where you select it, whether it be the folded model, the flat model, or the table, it will highlight the other two correspondingly, and you'll get that dynamic feedback. And it's really useful if you're trying to change in individual bend reliefs, individual rips, and you want to make sure you're changing the right one, right? Because I can select it in the table, it highlights in the graphics, and I can confirm, okay, this is the right edge. So again, the big thing I would stress is anytime you select a radius, anytime you select a joint in your table, you're going to get that feedback that this is the edge, corresponding edge on the model. So here we are in this example. This is the previous part that we designed, but I'm going to go into sheet metal model 3 here. And you can see this is the latest sheet metal part that we created. This is the third sheet metal part we created. And if I select the face here, notice it highlights in the flat view and it highlights the joint in the table, right? So again, select the bend here, highlights here, highlights here. So I know that that bend is joint B. If I need to change the radius for whatever reason, I can do that, right? I know which joint that it is. So again, and it doesn't matter where you highlight. If I select here, it tells me, okay, that's the bend over there, right? And that's joint D in the table. And it doesn't matter whether you click here, here, or here, it's going to highlight the other two, right? Question, does Onshape have any fold and unfold functions? No, it's a live flat view constantly. Now, I will say that you can do things like cut across folds and things like that. So if your issue is I'm trying to unfold, create a feature, and then fold it back up, just try creating that feature in the folded state. It's very robust in terms of cuts around corners and bends and things like that. Question, I've had difficulty creating an opposite hand part from a sheet metal. Is it possible? I don't think so. The opposite hand functionality would require like a mirror, and I do know there's some limitations to mirror in sheet metal parts. So if we're talking about the same thing, creating an opposite hand part from a sheet metal, I'm thinking of using the mirror command, and I do know that there's some limitations to mirror and be able to unfold. All right, so the next tip that I have for you, jumping back here. So again, to highlight it again, when you select an edge or a radius, something in the folded view or the flat view or the table view, you're going to get highlighting in the other two. And it's just meant as a visual cue to help you understand, joint C is this, joint, this radius is joint D, and vice versa. So that's tip number 2. Tip number 3, this is another commonly asked question, is how do I change a flange length? When I select an edge for flange, I get the flange the entire length of the edge. But what if I want a flange that only goes to a certain distance? Or what if I want a flange that's centered in the middle or something to that effect? And the answer is you can use the move face command. And I can grab a face and drag it and change the flange length, and it will automatically add the bend or corner reliefs necessary as you're doing it. So we'll do it on the fly. So let me give you an example. Let's hide these other parts here, and let's do a quick flange to either side here. All right, so I'm going to add a flange to either side, and now the question then becomes, well, what if I wanted to change the length of the flange, right? When I do the flange, I select the edge, I get a flange the whole length of the edge. what I can do is choose the move face command, select the end faces of the flange. In this case, we'll do both of them at once. And then I can just grab and drag, right? Or input a value. What I want to point out here is it's automatically going to put in the necessary bend reliefs. So in this example, you can see I'm automatically getting those relief cuts in the sheet metal part. I can enter a specific offset if I want, hit the green check, okay, and now I've modified the length of that flange. But move face allows me to grab and drag, and because it's moving the face of a sheet metal part, it knows to add the necessary features. Question: can the sheet metal model be worked on by solid modeling commands without... Oh, forgive me, it's cutting off the question. I can't see the second half of the question. Forgive me. So can the sheet metal model be worked on by solid modeling commands without... I'm going to guess without changing back to a solid. By normal solid modeling commands, you can create any cut feature that you want to a sheet metal part. So a normal extrude remove works just fine on a sheet metal part. But remember, in order to unfold, it has to have uniform thickness. So you can't add a boss, for instance, to a sheet metal part without first finishing it. Right? I think that's what you're referring to as convert to a solid. But you have to finish the sheet metal model before you can add things that violate that rule of uniform thickness and the need to unfold. So, any kind of bosses that you want to put on there, any kind of gussets that you want to, anything that you would do after the part is folded in the physical world would be done after the finished sheet metal model. Right? And I'm going to show you that in just a moment. All right, so that is my, I think, third tip now. Tip number 3, move face to change the flange length. It's another commonly asked question. How do I change the length of a flange that I've created? So let's move on to the next tip, and that is sheet metal tab. And this is actually brand new. So if you haven't used sheet metal in a few weeks, we didn't have this command a few weeks ago, and it's something that was highly requested. It's something that a lot of users have asked for. I need to sketch in a tab and add it to my sheet metal part. And in the past, this was a limitation. There was workarounds you could do, but it was difficult. And now it's a simple matter of just simply sketching in a profile and adding it as a tab command. Question: if you pre-made punches and you want to boolean away from the sheet, to be honest, I haven't tried that myself. To be 100% certain, I'd have to try it myself. Can you do a contour curve? If by something like a spline, for instance, even a radius, you can't unfold as of today. One other limitation that we get asked quite often is things like squared around transitions. That's still a limitation as of today. There's workarounds that people have done. In fact, if you do a search in public documents, you'll find squared around workarounds and things like that. But there's no dedicated functions for those things today. With regards to pre-made punches and booleans, if the punch is just a circle or a certain shape, then you could just recreate that shape and do an extrude cut. I haven't personally tried boolean subtract on a sheet metal part that hasn't been finished, but I'd have to try to tell you for certain. All right, so sheet metal tab, again, the big thing is you have a sheet metal part, you need to sketch in some kind of a tab that's parallel to the face of the sheet metal part. Parallel sketch region is required, and essentially you sketch in the shape. If you look at the screenshot that you see on the left, we have that kind of tab slot boss that's been added to the sheet metal part. And the neat thing about our tab command is it has a few unique functions. So yes, you can just sketch a simple enclosed contour and add it to your sheet metal part. But you can also create several tabs at once, and you can use the tab command to subtract tabs from other sheet metal parts. And that becomes really valuable if you're trying to get sheet metal parts to line up, if you're trying to get 2 or more parts to line up together so that you can weld them or whatever it may be. Creating tabs that interlock is a valuable feature, and that's something you can do with this tab command. All right, so let's get into an example of this. Bear with me for a moment here. We've got a sheet metal bumper And it's actually 3 different sheet metal parts, right? So we have an upper, middle, and lower plate here. And you can see that I have a simple closed profile that I've sketched, right? That reflects, what I want the tab to be. It's parallel with the face of a sheet metal part. As you can see, the bottom face of this sheet metal part. And it's very easy to create a tab out of that. Now, the command, it's new. You'll find it right here in the toolbar, tab command. And it's real simple. You just choose the tab profile that you want. The profile is the sketch that you've created, right? In this case, this profile. And what happens is it merges with the flange that it's attached to. So you can see under flange to merge, it recognizes, okay, I'm going to attach to this bottom flange because that's where it's attached, right? That's where I created the sketch. But keep in mind, you can create a simple flange, or a simple tab, I should say, just like this. But I can also use this to create multiple tabs in a single feature. I can use multiple flanges, right? So I don't have to choose just one. I can say, well, this flange too, and it will take that tab and add it to that flange. I don't have to do a separate sketch, convert entities, create another feature. I can just say, create a second tab on this part, even though this is a totally separate sheet metal part. Right, it's not the same part. These are 2 different ones. This could also be, I want 2 tabs on the ends of the flanges on the same part. That works just the same. So if this were just one bent U-shaped part, I could do the same thing, where I'm creating a flange on both ends in a single feature. So it could be on multiple parts. It could be on the same part. It doesn't really matter. As long as they're parallel with the sketch, you're good. You hit the green check, and you have your tabs. Now, of course, the big thing with tabs is you'd expect to see them in your flat view, and of course, there they are. Right. So that is the sheet metal tab command. Again, that one is really pretty new, not even a week or 2 old now, and it was something that a lot of users requested. Now, the tip that I would have there is you don't have to go through the effort of creating multiple features, multiple sketches for each tab. If they're parallel, just use the single tab command and select multiple flanges, and it will automatically create those tabs on those flanges. All right, so one more very cool thing about the tab command. Another tip that I have is when you're doing tabs, it's very common to need to take and align parts based on tabs. Right, so I'd create a tab in one part and a cut in another part so that when I put them together, they sat where they should sit. They located relative to each other. That's a very common technique. So let me give you an example. Let's say that I have the bumper center here, and I have the bumper top, and I need a way to align the 2 when I weld things up. So I want to create a tab in this part and a notch in this part so that they can align. So this is an example where I'd use the same tab command. So I go to tab, I choose my tab profile. It will automatically choose this face to merge with. That was the face reference for the sketch. But then I can define a subtraction scope. And that's the key thing here. So at the very bottom of the tab command, you have subtraction scope. Think of this as, what do you want to subtract this tab from? Now, in this example, I want to cut a notch. I want to subtract the tab from the top sheet metal part so that I have the appropriate cut and they line up properly. So I can select this part, and what happens is it will cut the tab away from that sheet metal part. Right? So now I can get those 2 aligned properly. To show you what I mean, let me hide a part here. You can see there is the top part hidden. There's the tab that we're adding, and there is the middle part hidden. You can see the tab there cut out of the top. So that's the idea behind it. It allows you to quickly say, I want to subtract this one from this one and create those necessary cuts. Now, another question that often gets asked is, what if, it's not a perfect fit? What if I need, a small gap between the faces? You can define a subtraction offset. And I can say, I want, let's say 20 thousandths gap between the 2. And you can see there's now a small offset between those faces. But again, keep in mind, I think the subtraction offsets are really just, or subtraction scope, I should say, really useful in these kinds of situations where, I have multiple sheet metal parts and I want to align them. I want to align tabs to cuts or whatever it may be. So that is the sheet metal tab command. The two big tips, the two things that I always like to point out: you can create multiple tabs with a single feature, and you can subtract tabs from other sheet metal parts, giving you that ability to align them, right? To locate them relative to each other. So I hit the green check. There we are. Just to kind of show you the end result there. There's the tab in the center, and there is the cut in the top plate to match it. Okay. Question: can Onshape design the half of the symmetric part and do the mirror? No. I'm fairly certain about the limitations to the mirror command and unfolding a part afterwards. I haven't tried it personally, but I'm fairly sure that if you design a half and then try to mirror everything over it, it won't unfold. And that's, I think, going to be a limitation just in the mirror command itself. It is definitely something we're aware of. You're not the first person to ask for the ability to mirror and unfold. That's definitely something that's high on our list for sheet metal commands. But as of today, no. No, I would say I'm fairly certain that's going to be a limitation. All right, so moving on. That is tip number 4, the sheet metal tab command. If you haven't used sheet metal in a while, just keep in mind, the tab command can be used to create simple tabs, or you can create multiple tabs in a feature. You can do subtraction, scope, all kinds of cool stuff. Question: I assume individual features can be mirrored and copy transformed. Again, I don't. The key there is, do you have to finish the sheet metal model first, right? If I mirror an individual tab over before the finished sheet metal, I think that may be in and of itself still a limitation. The question: are louvers still tricky? This is a question that was asked earlier too. How do you make an emboss? It's not that it's tricky. Just keep in mind, anything, whether it be a louver, a standoff, a boss, anything that you would do after you bent the part, right? Think of it that way. Or after you cut the part, that you would do that as finish sheet metal. So I would finish the sheet metal, then I would do my louver, right? Or anything else, really. But that's really the way to think of it. Would you want to see louvers in the flat view? I think the answer to most would be no. I don't want to see louvers in my flat view. So again, think of the louvers, the standoffs, the gussets, anything that you would do after it's cut or bent as I finish sheet metal, then I do those operations. And it's just a step that allows you to do any kind of solid modeling to your sheet metal parts. Right. All right. So tip number 5, reorder the bins in the sheet metal table. This is particularly useful if you actually manufacture it in-house, or you just want to control that manufacturing process. Maybe you're the one that actually goes out and bins this part. The big thing I would stress is, what I've seen a lot of companies do is they'll create a bin list, a bin to order sheet, literally like a PDF that lists, here's how we bent this part. And really, it's just a list of orders of bins. So that the tooling clears or whatever. They figured out the necessary steps to get this bent with the tooling that they have. And the big thing I've seen is they'll create some kind of a document that says, here's how we made this. And it's really just a list of the bins in order. You can do this inside of the document. And keep in mind, it's built in as a function within the table. And the big thing I would stress there is, with the sheet metal flat view and table, we've tried to build in a little bit more manufacturing information than you may have gotten in the past. So I can take, if this were the first bin in my part, I can right click on it in the table and move it up in the bin list, right? So I can move up or move down in the bin list, and then come back to this 6 months from now and say, okay, this is the order that we bent this, right? Again, the big thing I would stress, this is primarily if you're actually making this part. Of course, if you're just sending this off to be manufactured, you may not care about this. But if you're manufacturing this in-house, or if you're the one that actually is going out and making this part, this could be useful for you, especially if you come back years later, right? What is a rip bend? I'm not sure I know what you're referring to there. You can convert a bend to a rip. Forgive me, I'm not sure what you mean by a rip bend. Your rips will show here. I don't have any, but you will see the rips. showing below. It's just, in this case, this example doesn't have any. All right, so you would need pressing dimensions. Oh, this is where the question earlier. Yes, and you can absolutely place, points and add dimensions to them. That's the way I've seen that defined in the past. But actually showing bent, actually formed louvers in a flat pattern is not a common practice from what we've experienced. If you're opposing bends on dies, you would need pressing back marks. If you're opposing bends on dies, you would need pressing back marks. Yeah, but I don't know that. Yeah, again, the current functionality just allows you to take any kind of operation after the part is cut and model that in a solid. Pressing back marks. I'm trying to think of a scenario where you would need pressing back marks. Dimensions in the flat view are simple, right? I can easily pop in dimensions for that. And what we may include in the future is the ability to reference a point or an edge or something with respect to that louver or boss or whatever it may be. But again, as of today, and what we get from most users, they don't want to see those things in the flat view. It just complicates things for the toolpath software and so on. So maybe an option in the future, definitely use the feedback tool under the help menu and let us know if that's a really critical thing for you. I would say I don't think we have tons of requests for it yet, but definitely use the feedback tool and let us know. If it's valuable enough to enough users, we can definitely throw that in. Bend up, bend down. I do believe you see manual notes. When you add a flat view to a drawing, you do see notes with bend angles and so on. And we're going to get to that in just a moment. All right, so let's move on to the next tip that I have for you, and that is exporting to DXF or DWG. Now, the question often gets asked, do I need to create a drawing, make sure I have a blank sheet, make sure everything's one-to-one, and then export that as a DXF? And the answer is no. You can right-click the flat view, and you'll have the option to export to DXF or DWG of whatever that flat view is that you're clicking on. It will automatically come out as one-to-one, so you don't have to worry about the scale. You don't have to worry about the title block or border or things mixing up in the CAM software if you're going straight to like a water jet or some kind of cutter where you need to generate toolpath. Oftentimes, title blocks, borders, scale can really trip up, those kinds of operations. So right-click the part in the flat view. You'll see the option to export DXF or DWG of flat pattern. That will give you your DXF or DWG at a one-to-one scale very quickly and easily. Now, the other question that often gets asked is, what if I need to add a drawing with bin notes to show the up-down direction and so on? And for that, you can create an actual drawing and insert a drawing view of the flat and so on. That stuff will come in by default when you insert a drawing view of a flat. So it really depends on what you're doing. I think most users today, they just want to, show me how do I go to my water jet? How do I go to my CAM software to generate toolpath to actually laser cut this part? Show me how to do that. And the simple answer is just right-click your flat view here, and you'll see the option Export DXF, DWG. Choose the format that you want, and then hit Export. And it's going to save it as a DXF on your local machine. Drop that into your CAM software, and you're off and running. You don't have to worry about, again, scale, title blocks, any of those kinds of things. It's strictly geometry exported out of Onshape. So that's the simple answer if you're going straight to the manufacturing process. The other question that often gets asked is, what about, I need to create a drawing. Let's choose Nancy C. I need to create a drawing, and I need to see those flat views and maybe even bin notes and things like that. And this is actually something that's relatively new. The ability to insert that binned information into the flat view wasn't there initially, but of course is now. The big thing I would stress, make sure to click this button in the insert dialog. So as you first create your drawing, there's a little button here for flat patterns, and that's just going to turn on the ability to insert your flat patterns, right? So choose a flat pattern here and drop it in to my view, right? And there's my bin notes, up, down directions, and so on. And these can be moved around. You can drag them around and so on. But again, to keep in mind, if all you're looking for is that up-down angle, you can drop that into a drawing view, and it will automatically insert all of those details. So again, that's exporting to DXF, DWG. Another commonly asked question is, what if I want to take this drawing and export it to DXF or DWG? You just right-click the tab, and you'll see the option to export. Right, DXF, DWG, even PDF, if that's what you're interested in. So that's exporting. Again, the big thing I would stress, you can just right-click the flat view. If all you're doing is going to, laser cutter, water jet, I need to get toolpath generated, just right-click the flat view, export to DXF, go straight to a DXF without worrying about the drawing process. If you're looking for up-down bend notes and angles and things like that, you'll need to insert the flat pattern into a drawing view and keep an eye on that small option in the insert dialog. It's not on by default, so you'll need to click that, and then you'll have the option to insert those flat patterns into your drawing view. All right, so moving on. The next tip that I have for you. What about louvers, feet, standoff? This is a question that's been asked a few times now in a few different ways. And the key thing I would stress is, again, if you're going to do it after you cut the part, you want to finish the sheet metal model in Onshape. And that's the way I would think of it, right? So if I'm going to add a louver, I'm going to do that after I've cut it. If I'm going to add weld-in standoffs, I'm going to do that after I cut it. So anything that you would do after you've finished, after you've cut the part, think of it as after you finish sheet metal. That's the way that it was built. And the key with finish sheet metal, it's a very simple command. You just say this sheet metal part's done. Is now you could do anything that you want to it in terms of extruding bosses and all those kinds of things, because you don't have to see that in the flat view. And that's the key thing. Anything that you add in terms of bosses, louvers, standoffs, anything that kind of violates those rules of unfolding, you won't see it in the flat view, and most won't want to, right? Because they would just confuse the CAM software in situations. So, again, just keep in mind, think of it as anything that you do after the part is cut, finish the sheet metal, and then design it in that way. So again, pretty straightforward. Finish sheet metal is a very simple command to show. So I'll show it to you real quickly here. Let's bring back another part here. Let's say, for instance, that I wanted to add a few standoffs to something like this part. If I go to extrude a boss and merge it with this part right now, it will not work. The same thing goes for louver. If I wanted to cut a certain formed louver shape into this part right now, it would not work. And that's because the sheet metal model hasn't been finished. And so that's the last icon in the toolbar that you'll see here, finish sheet metal model. Now, for some, you may never need this command. So this isn't a requirement unless you have, solid features that you need to model in. So just realize, if you don't have a need for that, you ignore this. You'll never need finish sheet metal. But if you need louvers, if you need standoffs, if you need gussets, you need any of those things you would weld in or manipulate after the part is bent, you'll need to finish sheet metal. Very simple command. All you do is select the sheet metal part you want to finish. That's literally all there is to it. So you say finish sheet metal. I select this part. Okay. And now anything I do will behave just like a normal solid part. It's going to behave no differently than anything else. If I go in and, extrude, let's say a circle here, forgive me for doing this quickly, but I can extrude a standoff. I can extrude a louver. There's even custom features that allow me to do that pretty quickly. Dummy. Try that again. Add a few dimensions because we need dimensions. Right. And I can extrude this, right? Extrude. And the big thing is I can merge it with this part, right? That's what would fail if I hadn't finished the sheet metal. Is when I go to merge scope and I say I want to merge with a sheet metal, that's when it would come up with an issue. It would have a problem. So just keep in mind, now I can hit the green check. Now I've got my extruded boss, my standoff, whatever it may be, protruding from my sheet metal part. The big thing is when I go into my sheet metal model, you will not see it here, right? And that's by design. That's deliberate. So just keep in mind, think of finished sheet metal as here's the things I need to do after the part's cut, and I add that after I finish the sheet metal. Now, question, this is a good question that comes up often. Can we undo or delete a finished sheet metal so we can make changes? Yes, absolutely. So what you would do is just simply roll up above it. right? Roll up above the finished sheet metal in the tree, add anything that you need in sheet metal features, and then roll back down, all right? So just keep in mind, you can roll up above it. Yes, you can delete it, but then you're likely to have an issue with the feature that's tied to it failing because, again, in that scenario. But yeah, roll up above it, roll down below it. That's an easy way to undo or go before you finish the sheet metal. Remember, finished sheet metal is just a step in the feature list, which means you can roll up above it and it's a sheet metal part again. You can do anything you want, roll back down, and it will be finished again. Much like any solid modeling feature in that sense. But again, think of it as a feature. It's calculated in order, just like any other feature in the tree. Sorry, I come from a time when there's no CAM software for Armada Prespec. Where's the library of custom features that are useful in sheet metal design? Nothing yet. We do have one example that I've seen in custom features, but we don't have a library of custom features for sheet metal design as of today. Now make an emboss. Let's see. I think I have an embossed foot feature. I would have to play with this a bit. Bear with me. What I would recommend, let's try this. No. I would recommend checking out the embossed foot. The reason I bring this up, this is an example. This is a question that was asked with regards to library features and embosses in general. There's a feature. It's under feature script samples, embossed foot. There we go. Embossed foot. This is a command that will create embosses in your sheet metal part. Just simple circular embosses, but it's a good example. Their code is open source, so you can take this and build your own embossed foot feature. All it really does is in this case, it does a simple Boolean subtract from the part. So you create in this case, I think it's even a revolve, Boolean subtract it from it and create your feature. But it's a great example of embosses, louvers, something like that, where you want to automate it just by clicking a point. That's the closest thing that we have today to a library feature. We don't have any custom louvers or library features as of today, but it's just a matter of creating a solid feature, Boolean subtract from the sheet metal after it's been finished. All right, so let's move on. I do have one. No, that was it. That was my last tip for you here today. So again, just to stress, louvers, feet, standoff. Stick around. I'm going to try and find a public example to go through with you. But the key thing there is make sure to finish the sheet metal model before you create your louvers, your feet, or your standoff. And then from that point forward, you can model a louver as a solid feature and do a merge with the sheet metal part or a subtract with the sheet metal part. So it behaves no differently than a solid part in that sense. So again, louvers, feet, standoff, the key is make sure to finish the sheet metal. Then you can create any solid feature that you want. All right, so that's what I had planned. I have a few questions that I haven't answered, so I'm going to stick around and make sure to get to all of them. So bear with me. I am going to stick around too and see if I can find a good example of a louver that's public to send everyone. So bear with me, but make sure to get your questions asked. There's a question section there in the GoToWebinar control panel. I will make sure to stick around for as long as there's questions remaining. So that's what I had planned. I want to say thank you, everyone, and have a good day.